particular question has to do with half-life of a radioactive element. Then the question is very simple. It says, an element whose half-life is 3 years has any atoms. The half-life of this element, where is my chalk? The half-life of this element is simply 3 years. Solution. Let's go. Let's see. Half-life. T half is equal to 3 years. Okay? 3 years. How many atoms? How many atoms would have decayed after 9 years? So we need to know the number of atoms that would have decayed after the element lasted 9 years. Remember, in every 3 years, it has to split. It has to die off. Part of it, half of it will die off or decay, right? So that is it. Every 3 years. Part, half of it. So let's see what that gives. If we say the first 3 years, okay, the first year or first cycle, we have first one, first 3 years, okay, I'm going to abbreviate this. We have half of it decaying, right? That is half we decay. We will iterate this until we arrive at 9 years. So let's take it again. The first one, the first cycle of it, 3 years, half of it will decay. Take note. Second cycle of that radioactive material, another 3 years, all right? Okay, another half will decay. So what do? Half the first one, all right, times the second half. And this will give us 1/4. This will give, here is a 1/4. Good, we keep it. Then the third year, the third time, the third cycle of it is another 3 years, right? Which is giving us this. What we have here is 1/4 times half. Because every 3 years, half of the radioactive element will decay. That's what it means. So this will give us what? This will give 1/8. 1/8. 1/8. Let me write it toward the other side. So we then have the first one. First one is N/2, half decays. Second cycle of the radioactive elements, what decays is N/4, right? And remember, this happens in every 3 years, right? Take notes. Okay? Another year is 3 years. All right? Then the third cycle of the radioactive elements, what happens? Look at it, 1/8, that is N/8. And this happens in another 3 years. Okay, so let's see. Quite interesting, isn't it? Total years. 3 plus 3 is 6 plus 3 is 9. Total years here is 9 years, right? Good. How many atoms happens here is N/8. But there is something here. We need to know the fraction. How many would have remained after this? So what we need to do is N, which is the atom itself, right? Then minus what we have after 9 years, minus N/8. So if we do this, we will then arrive at, we find something very simple here. The LCM here remains 8, okay? And this is just all over 1. So 1 divided 8 takes that 8, times this becomes 8N, right? And then 8 divided itself is just the same thing as 1. Then times this, that is minus N. Okay? So invariably we have that. 8N minus N. And finally, our answer here becomes 7n all over 8. That is what the answer should be. 7n all over 8. That means the number of atoms that will remain after 9 years is simply 7n over 8. So let's see. Option A is n over 8 atoms. No. Remember, this is atoms. This is number of atoms, okay? Then option B is n over 3 atoms, which is different from what we have. Option C is 2n atoms over 3, also different from what we have. Then option D is 5n atoms over 6, not the same thing. And finally, option E, 7n over 8 atoms. And we have 7n over 8 atoms would have decayed after 9 years. Therefore, the most appropriate answer or option is option E. So that is it. That is solved. See you in my next class.